I previously introduced atomic vectors in R, which require that all the elements be of the same type. In this video, I'd like to introduce list vectors, or just called lists, which are super flexible because the elements can be a mix of any type or pointers to objects, including an element in a list can be another list, a sublist. I'd also like to show you how to retrieve elements from a list, because this can be tricky. If we don't want to retrieve a list from a list, but we just want to get the element from the list, we need to use double brackets. So list, double brackets, value of n returns for us the nth element of the list. If that element has a name, we can use double brackets, and the name in quotes would also return for us an element, not a list. And finally, the shortcut, the most useful, is if we've named the element, we can just use a $sign. So this is just generically or generally list, $, name of the element, returns for us the element of the list. Before I walk through the code that creates a list and retrieves elements from the list, I thought it'd be helpful to visualize the difference between an atomic vector and a list. So here's a visualization of 3 atomic vectors. These are the names of the vectors. So here is VEC_DBL, that's short for double. This is the name of an atomic vector with a length of 3, and all of the elements are of the same type. That's a requirement of the atomic vector. In this case, they're double. Here is a different vector with a name of VEC_char, short for character. This vector has a length of 2, but again, both of the elements are of the same type, this time character. Finally, here is VEC_log, short for logical. This is an atomic vector, length of 4. Each of the elements are type logical, also called Boolean. So that's horizontal. I'm going to take those same vectors and just flip them vertically. So we have 3 atomic vectors, and I'm putting the names at the top as column names, so to speak. So you can see here, but they are 3 separate atomic vectors. Key feature of that atomic vector is that each of the elements in the vector need to be of the same type. In this case, double. In this case, character. In this case, logical. Now, I can create a list. And notice the only subtle thing I've done here visually is I'm just combining the 3 vectors. They become objects in a list. So now I have a list, and this list has 3 elements. Here's the first element. It's a double vector. Here's the second element of the list. It's a character vector. Here's the third element. It's a logical vector. Notice, unlike a data frame, they do not need to be all the same length. That's really the key to a list. And I'll just go one final step here visually. I'm going to add another element to this list, or add 2 more elements onto the end of this list. This 4th element, and we'll do this in the code, becomes a list itself. So I'll call that a sublist, and I'm going to give it a name of sub. But so that 4th element of the list is another list. Let's call that a nested list. I'm also going to create the 5th element. I'm going to call it funks, short for functions. And it's going to be a list of 2 functions in R that we can actually access. So now I have a list of 5 elements, each of whatever length they are, they don't need to match, and each of whatever type, including it can be a list or even functions in R, but I am going to be able, you'll notice here, to give a name to each of these elements in my list. If I don't do that, then this is going to be called the first element, the second element, and the third element. I can use 1, 2, and 3 right away, but I am going to go in, and it's going to be easier to actually give names to the elements in my list. Vectors are one-dimensional data structures, and in R, a vector comes in 2 flavors. It's either atomic or it is a list. Atomic vectors I covered in the previous video in this playlist. The requirement of an atomic vector is that all of the elements need to be of the same type. 4 most common types are logical, integer, double, and character. Integer and double together are the numeric types. Double stands for double precision floating point, and that's when we need a number that's more specific than an integer, like a rational number. If the vector is not atomic, then it's a list, because a list is the flexible data structure where the elements can be of any type, meaning that we can mix the different types. And an element of a list can be another list. So that would be a nested list. That list itself has elements, one or more of which could be an additional sublist. So we can nest list elements, and we often do. Here in the code chunk, what I've just done is I'm going to create a variable. I'm calling it li, short for list, and I'm using the list command, which in R very naturally creates the list for me. You can see I open parens, close parens, and I'm just using the format here where each row is one element of the list. I have 5 rows, so I am creating a list with 5 elements, and so I'm just going to hit Control Enter in RStudio. And helpfully in my environment panel, which is so great, I can see that I've created that variable called li, confirming for me that the data structure is a list of 5 elements. And so you can see my first element in this list called li is itself an atomic vector of type character. We just call that a character vector, and I'm getting that feedback right here. First element in the list is character, length of 4, and I'm getting the head of it, which in this case it's so short that that's all of the values in that vector. My second element, I just used a sequencing command here, 1 to 10. So my second element, you can see here, R decided to deem that to be an integer vector, length of 10. My third element, notice how I'm mixing and matching here, including with the lengths. I have a length of 4, and then I went to a length of 10. These are not equally linked like they would be in a data frame. Another part of the flexibility of the list here. My third element is a logical vector. My fourth element, I just wanted to illustrate how I can nest the list. What I've done with the fourth element here is created another list inside the list, and you can see I get that feedback here. This fourth element is a list of 2. What are the 2 elements in that sublist? Well, they are each a vector of different types. I have an integer vector and I have a character vector, each of length 3. Finally, my fifth and final element in this list, what I've done is combine here with the C function is 2 of the functions in R, mean, which is the average, and sum, and that's a common function in many languages, right? That's a summation function. So these are functions in R, but what I've done is the fifth element of my list called li, I'm storing functions, or specifically here, that fifth element is a list of 2, and that list contains 2 elements. The first is the mean function. Notice the feedback here I'm getting. It's not a vector, it's an actual function, and my second element of that sublist is the summation function, and I'm gonna go and use those shortly. So the hardest part for me in learning lists was this part here, and that is how do we select from the element. And I just remind you that if when we did simple vectors, if I create a simple vector here, and I'll create a simple numeric vector, 1, 2.3, and 5, so I'm creating there a double. That's just a simple vector. To select or retrieve from that, I just use the square brackets, right? If I want the second element in that numeric vector, I use, I didn't give it the right name, simple vector, right? I just use square brackets to retrieve the second element, which is 2.3. So I have this list called li, and I can go and select here the first element using that square brackets syntax, right? That's just very common in R. What am I getting back? I'm getting back, I had a list of 5 elements, and what I'm getting back is a list of 1 element. So, and you can see I've noted this here in the comments. When we use the single brackets that for me is the natural when we go from the vector to the list, and when we subset or select or retrieve from the list, what we get back is a list. So in this case, I got back a list of 1, and really that's being betrayed here by this label here that's telling me, here's your list of one element, and that first element itself is a character vector, and this one here indicates that we're starting with the first element in that vector. And see, I could even check that with the structure command, right? Wrap that here, wrap it with structure, and to confirm that that is a list of one. But let's say I really don't want a list of one, I want the actual element, not the list, right? Single brackets gave me a list, I want the element. Well, I need to use double brackets for that. And see, I've noted that here. Single brackets returns for me a list from the list. It's double brackets I need to use if I actually want the element. So I hit Control Return, and now I am getting back the character vector, which I could even confirm using that structure command just to check that. And you can see I'm getting back a character vector of length 4. And one thing that we end up doing in practice is we name the elements in the list. So now I'll go down here and I'm going to start by just creating a vector called nums. I'll refer to that as a numeric vector, even though specifically it's an integer vector I've just created. And now I'm going to go and recreate my list here with a similar command, but this time, right, instead of just listing one element per row, I'm going to go ahead and give each element in this list a name. Right, I'm going to call this stocks because these are stocks I own or owned at one time. And the second element, I'm going to call that nums, and it's actually going to contain the nums vector, right? So this is the name, and that's the actual vector. My third element, I'm going to just call that own, as in do I currently own the stock. That's true for 3 of them, false for Starbucks, not anymore, I sold it. And then here, I'm just going to call that sub because it's a sub list. And here I'm just going to call this funcs because this is a list of 2 functions. That's the 5th element in my list of 5. So pretty similar to before, except now I'm naming each of the elements in my list, and I'll hit Control Enter. And you can see our studio, I love this panel, gives me that feedback immediately. Much the same, except now we have the handy names before each of the elements. So I've noted this here in the title. What we are assigning names to elements of the list, and just so we know specifically what's going on here, vectors can have attributes. I haven't talked about that before. So attributes are very flexible. A specific kind of attribute is the names. Names are special because they're not temporary. They don't get erased just because we modify the vector. So it's common to give names to vectors, and in this case, we're giving names to elements in our list. And I can actually go down and just check that with the names command for li, and it's going to return for me the names of the elements in my list. So you can probably figure out why I did that and where I'm going next. I'm actually going to subset or select from my list using the name. In this case, li, let's see, stocks is my first element, is the name of the stocks. I need to put it in quotes. Might think for a second, wait, what are we expecting to get back here? Are we going to get a list or an element? Remember, single brackets, when I single bracket select from a list, I get back another list. It may or may not be what we want, but it is what we're going to get back. And it's betrayed here, you can see by this line, telling me here is the name of this list of 1 that you're getting back, where that first and only element is itself a character vector. So I could use that combine operator to combine stocks and, let's say, my other own. And so there I'm taking my li list and selecting using the name, but a combination of 2 names. And now what am I getting back here? I'm getting back a list of 2 elements, first element and second element. But what if I just want the elements? I don't want a list. I just want the stocks. I want the character vector here of stocks, not as a list, but as the element itself. Well, we need the double brackets. That's the key thing that I wanted to impart here. square brackets on the stocks instead of single brackets, and I get back. Notice I don't have that list label. I'm just getting back the element, not the list, which itself is a character vector. I could even confirm that with the structure command. I do this a lot myself in confirming it's a character vector. So I got back the element with double brackets. Okay, so now here's the shortcut. The shortcut is the $sign, right? Because this double square brackets is pretty clunky or clumsy, and the shortcut that's equivalent to that is the $sign. So notice I typed in the list and then the $sign, and RStudio immediately pulls up the names of my elements in the list, including stocks. And so I just select that, or I could have hit tab. If I go back here, right, just hit enter. And now this command is equivalent to this. What I'm asking for is the element, not as a list, that is named stocks within the li that's a data structure of list. And I get back the, not a list, but the actual element as a character vector. And so I could have done this with own as well, for example, right? I get back the logical vector. So in practice, this $sign shortcut is what we end up using. Okay, now I'm going to use that fifth and last element of the list, which is a list of two functions. I think this is sort of cool. I'm going to do li $sign, and I'm going to reference the functions as the name. That is a list of two functions, right? And so as a list, let's say I want to pull out the first one, which was the mean. If I want to pull out that element, which is the function, I need double brackets there. And the one means my first element in that sublist. So what I've done with that command is pull out the mean function, and then I'm just going to put in 1 to 10. So you can see what I'm just doing there is running the mean or average on the sequence from 1 to 10. Let's see if that works. 5.5, it works. So again, li, I'm going to, the element called functions, and I want the second. Now I'll take the second element of that sublist called functions, and that's the summation. I'll run that on the sequence 1 to 10, and I get 55. So wait a second, could I have used another $sign there? Well, the problem there is I didn't name these functions, so I can't yet. But if I go back up to li here, I'm going to redefine my list, but this time I'm going to call the first function, I'm going to give that a name of average and rerun this. Control Enter. Notice the only thing that changed over here is now, again, I've got my li list of 5, fifth and final element is a list of 2, and that sublist, the first element, what did I get? Okay, yeah, has a name of average. Now that I've given it a name, I'm going to go down here and replace the double square brackets with average. Take that out. Let's see if that works. Now I'm saying, okay, li is my list. I'd like the named element functions, which is itself a list, and I'd like to refer to the named element average, avg, which is the average function. And it works. I'm executing on the sequence 1 to 10. Two more examples. First one real quick is just per the R cookbook as a usage of the list as a name value association, or really just as a, let's just call that a lookup table. So we can use this as a lookup table. And here what I've done is I'm creating a list called ticker. I'm going to hit Control Enter, right, where I'm giving each element here a name of the actual ticker, and then the element itself is really it's a scalar, it's a character vector of length 1, right? So here's my ticker, here's the actual character value. So that's ticker, and then if I want to create a string with a concatenate function, I can say the company is called right? And then comma, I'm just going to concatenate that character string with a lookup by referencing my list ticker, and I'm just going to use the name ticker $FB, and you can see the company's called Facebook. So I've used the list as a lookup table. Okay, finally, what I really wanted to show you is an application, a very realistic application of using the list, where it really comes in handy to understand the list structure. And in that case, this is with a very simple regression model. So using built-in data structure in R, the simplest one I could find was there's a data frame called women. I'm just going to print it out, and it's just 15 rows here of height and weight. There must be 15 women, where we have height in inches and weight looks like in pounds. Very simple. And now I'm just going to execute a command in R that we don't need to understand in detail, but this is just a command that creates a simple linear univariate regression. LM is for linear model. I'm going to store it in the variable called model. I'm going to create it here, and all I'm going to do is ask R to create a regression, regress weight on height. In other words, can I predict weight from height based on just a univariate regression using the women data frame, right? Real simple, at least compared to how we would do in Excel, I think. I'm going to collapse my LI, and notice what appears for me, or what I've done is I've created that linear model, or really R has done all the work for that. And notice the regression model itself is a list of 12 elements. So super cool, right? A lot of the complex work is already done for me. So there's actually a lot of information about this linear model that we don't need to go into now. The point I wanted to make is that it's creating a list of 12 for us. And notice the first element, we can now understand, is a named vector, and the name of it is coefficients, and it's a numeric vector of length 2. That's what we expect, right? We just did a regression of weight against height. So the coefficients here only needs to be linked to. We're getting a slope coefficient and an intercept coefficient. I could even I could get a summary of the model, which prints out that list object for us in a handy format, gives us all the information about the linear regression model, and I could check the structure of the model, of course, and confirming that it's a list. Again, that first element coefficients, and I'll just note that that first element is a numeric vector length 2. Here's my intercept, here's my height. That vector itself is using that names attribute, right? It has attributes, the special case of attributes of named. So the values in this vector have been assigned names. They are respectively the intercept and the height, as we would expect. So knowing this is a list, we're now in a good position to know that, well, it's probably natural to ask for the coefficients with the typical single bracket request, single brackets 1, and we now understand that it's a list of 12. This is going to give me back not the first element, but a list of 1, right? So if I hit Control Enter, you'll notice I'm getting back, it's betrayed here by this coefficients label, which is the name of that first element. I'm getting back a list of 1, which I could confirm with the structure command, right? List of 1, which is the coefficients. And the same thing would happen to me if I could use the name, but I get back a list of 1, maybe what I want. And we understand now that if I don't want a list, but if I want the element, which itself is the numeric vector length 2 of the coefficients, then I need to use double brackets. And now I do get back a numeric vector length 2, but I'm also getting the with their named attributes, the intercept and height, so that's handy. And further, we know that realistically, we're going to use the shortcut. $coefficients is equal to the double brackets, giving me back not a list, but the element with their names. Finally, maybe the intercept is not interesting to me for other purposes. I just want the slope. That's the slope coefficient here. It's 3.45. By the way, what would that mean? Well, that would mean that the linear model is telling us that for each 1 additional inch in height, that's associated with a plus 3.45 pounds based on this very small data set. But now let's say I just want to go in and get the slope coefficient. Right, we've got to remember what kind of we've got to remember what kind of data structure we have here. I can use $ coefficients, which I just did before. What is that getting back for me? That's getting me back for me a numeric vector length 2. Okay, I've got a vector. I can just go and get the second element of the vector, and I get back just the slope coefficient. But of course, if I can do that, then I can also use its name of height. Same result. So that's basically an overview of the list data structure and how we extract elements from it. Remember, single brackets to get the to retrieve a list. Double brackets when we actually want to dig down and pull out the element. If the video was helpful, stay tuned, subscribe, and you'll get the next video, and I'll do in this series on R programming. Thank you.